Translation definition in geometry. A translation in plane geometry is a type of geometric transformation where the original figure is moved in a given direction to new coordinates on the grid. In geometry, there are horizontal translations, vertical translations, or a combination of both. Translation of shapes. Translations allow you to move any shape or figure on the coordinate plane with great precision. When translating a shape, every vertex on the shape will move the same number of units. A translation moves the shape from one location to another while the angles, length of sides, and total area of the shape remain the same. The properties of translations, that the new figure is a faithful reproduction of the original figure in every way except location, means the image exactly matches the pre-image, but appears in a new spot on the coordinate grid system. Translation rules. Translating any shape or point on a coordinate grid follows certain guidelines. 1. Referring to the original shape or figure as the pre-image. 2. Referring to the newly located shape as the image. 3. Moving every part of the pre-image the same distance in the same direction to create the image. 4. Allowing no rotation, expansion, dilation, shear, stretch, or rotation of the pre-image in placing the image. 5. Using correct notation to indicate distance and direction of the translation. A translation is a rigid transformation, aka an isometry, because it does not change the size or shape of the original figure. Translations are the simplest transformation in geometry and are often the first step in performing other transformations on a figure or shape. For example, you may find you want to translate and rotate a shape like this. You can perform 7 types of transformations on any shape or figure: translation, rotation, dilation, expansion, shear, stretch, and reflection. Translation notations. The original reference point for any figure or shape is presented with its coordinates using the x-axis and y-axis system, xy. Suppose you have point P located at 3, 4. Point P is the pre-image. To avoid confusion, the new image is indicated with a little prime stroke, like this, and that new point is pronounced P'. How to do translations. You can know how to slide a shape using the TAB system, where T stands for translation, A stands for horizontal movement along the x-axis, and B stands for vertical movement up and down the y-axis. Suppose you were given instructions for point P at 3, 4 like this: T, 7, 2. That system tells you point P has a horizontal shift of 7 units and a vertical shift of 2 units. Since both are positive numbers, the shifts are in positive directions. To get our coordinates for point P', we use this formula. We are just adding the number of units for our shift to the existing coordinates, so we have 3 plus 7 and 4 plus 2. Our new point has an x-coordinate of positive 10 and a y-coordinate of positive 6. In the formula, the arrow indicates this is a translation. Now let's translate a line segment. We can write out our TAB instructions so that we must move the line to the left 1 unit and down 2 units. Now we apply these instructions to each point. Start by translating point H. Next we translate point I. Our new line segment, or the image, has 2 points: point H' at -3, 4 and point I' at 0, 0. The steps are the same for all geometric shapes with endpoints on the coordinate grid, whether you are translating a triangle, quadrilateral, or dodecagon. As long as you have your TAB instructions, you know how to move every point. Translation examples. Let's look at a few examples. Here is an irregular octagon translated following the instruction T82. Here is a septagon, translated down 2 units and over to the right 4 units. The TAB notation for the septagon is T-2, 4.